Hello, this is the third part in the heating cooling curve calculations. What I've done so far is I've set up the problem. To refresh your memory, the problem was this one here where we're calculating the heat that's required to take 30 grams of ice at negative 80 degrees Celsius and get it up to 150 degrees Celsius. We're looking at two types of phase changes that are going to occur. We're going to melt the ice and then we're going to convert it to steam. So there's going to be melting and boiling that's going to occur. So basically we had to break this problem into 5 different parts. So you got part 1 where you're heating the ice, part 2 melting, heating the water, part 4 boiling, part 5 heating the steam. We have to do these 5 different ways essentially. We're really using the same 2 types of calculations, just different numbers in each. In the last video tutorial I showed you how to calculate parts 1 and 2. In this one today I'm going to show you how to calculate 3, 4, and 5 and put them all together. Okay, so I'm going to take that water that I converted into, well, the ice that I converted into water, and I'm going to heat that water up first, then I'm going to convert it to steam, and then heat the steam up. There we go. So I'm going to do for part 3, I'm going to calculate the heat transfer. Now in this part what I'm doing is I'm heating the water up. Now remember, going back to this real quick, if there's a change in temperature, notice there's a change in temperature here, I'm going to use delta T, therefore Q equals MC delta T. So really what you're looking for is the change in temperature. If there's a change in temperature in this portion of the problem, you're going to use Q equals MC delta T. If it's flat and plateauing, and you're going to use a change in enthalpy. In this case, you're going to use a change in vaporization, okay, which is 40.7 kilojoules per mole. Okay, all right, so back to the calculating part as the dog's in the background barking. All right, so mass, specific heat, change in temperature. All right, my mass is going to stay the same, 30 grams of water. And what I'm going to have is a specific heat. And now that I'm dealing with the water in the liquid phase, I'm going to use 4.18 joule gram degrees Celsius. Don't forget those units. My change in temperature, essentially I am in that change in temperature range, just to jump back really quick, from 0 to 100. Okay, so I'm going from 0 to 100. So my final temperature is 100. My initial temperature is 0, so I'm going from final minus initial, so therefore that will be 100. Plug all that information in, and I can solve for my change in temp, or my transfer of heat, which is 1250 joules. Oop, strike that. 1, 2, 5, 4, 0 joules. Okay, so if I go back to my chart to keep track of my numbers here, what I'm going to do is go ahead and put the blue one in here. I'm going to put 12,540, and that's in joules. So as I did before, I'm going to convert this to kilojoules. The importance of using units of 1, 2, 3, 12.5 kilojoules. Okay, all right, so that's part 3. Part 4, okay, if you remember for part 4, what we're doing here in part 4 now is we are phase changing. So this is going to be very similar to what I did down here for the part 2, where I phase change. The only difference is I'm going to use the different heat of, what was the word I'm looking for here? Heat of vaporization. Here I'm going to use heat of fusion, right? That's what I used down here, was the fusion. Here I'm going to use the vaporization. Okay, so let's do that calculation. I don't know what that is, but let's erase that real quick. Okay, back to this. So here I'm going to do is use the heat of vaporization, 40.1 kilojoule per mole. Okay, so again, whether this is positive or negative depends on whether you're adding heat or if you are absorbing heat. So in this case, since I'm adding heat to the liquid to get it to vaporize, to get it to boil, I'm going to have this be positive, so it's endothermic. So I'm going to start with my 30.0 gram vaporization, and if you do this calculation, you're going to end up with 67.76. And your units, if you're not sure, units are going to be kilojoules. Okay? All right, let's do the calculation for part 5, and then I'll add that in together with part 4. Part 5, in case you forgot, drag back again, is now the heating of that steam. So now I've converted it to steam. My next step is to convert it now to a higher temperature. So again, since I have a change in temperature, Q equals MC delta T is applicable. Again, 30 grams. Specific heat. Now that I have steam, I'm going to have a different number here. And the number here is 1.84 joule gram degrees Celsius. My change in temperature is going to be final 150 minus 100. Think about these changes in temperature, just to make sure you're aware of this. You're only going to go for this range here. So you're going to go from this segment here to this segment here. So you're not going to go back all the way to the beginning each time. So I have a change of 80, I have a change of 100, and I have a change of 50. Okay, so keep that in mind. You're not going to do those all as one overall change in temperature. So calculating all of this, again, watching your units. Remember, grams cancel, Celsius cancel. So this is going to be in joules. And I end up with 2,760 joules. And I can convert that to 2.76 kilojoules. Alright, so now what I can do is I can come back and get rid of this. So I got my final 3 calculations. Right here, I've already plugged one of them in. I'm going to come back to my overall calculation sheet here, summing up each of the 5 parts. Kilojoules. Kilojoules, 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 kilojoules. Make sure that they're all in the right units. Obviously, I want to use kilojoules because I'm going to have everything in the thousands. So my final answer, when you add up all of this, is going to come out to 98.1 kilojoules. 3 significant figures because of the 3 significant figures in the mass of the water. Okay, so if you want to, you can come back to this chart here. I'll get rid of this one. And this total energy from beginning to end is going to be 98.1 kilojoules of energy. That's what Q total is. So if I want to get water to go from negative 80 all the way up to 150 degrees Celsius, I'm going to have to add this amount of heat to the water. Now this is a long problem. That's 5 steps, not too common that I'm going to give you. Well, I'm not going to give you something like this on a quiz or a test. There's no way. That's a lot of parts. What I'm probably most likely going to do is give you a section like this, where you'll calculate just these two. I might give you something like this, where you're calculating these 3. That way I'm checking to see if you know the changes in temperature, that you know how to use the heat of fusion. You know, at most 3 parts, at minimum 1 part, I suppose, but most likely you can have some sort of combination of the 2, because I want to know if you know how to use when the change in temperature is constant and when it's changing. So there you go. That's how you go from ice to liquid water to steam. Thanks a lot.